Lesson 2.8, Evaluating Functions. Functions can be written in a form called function notation, which we discussed a little bit in the last lesson. Function notation looks like this. This is read as f of x equals 6x minus 7, or it can be read as 6x minus 7 is a function of x. This function can be evaluated for various values of x. This is similar to the concept of evaluating an expression, which we have done before. For example, in the past, we've said to evaluate 6x minus 7 for x equals 3. And what we did was we plugged in the 3 and worked that out. Only this time, we're evaluating it as a function, so it's written differently. We say f of x is equal to 6x minus 7. Find f of 3. Sorry, I did not mean to do that. So here's how we'll do that. F of 3, we take the x out and we replace it with the 3. So I get 18 minus 7, which is 11. So f of 3 would be equal to 11. So we're going to evaluate some functions. We'll find the following. We have two different functions here, f of x and g of x. We want to make sure that these letters match what we're trying to evaluate. So when we're saying f of 6, we use f of x. And we want to find g of negative 3, we use g of x. So f of x is negative 11x plus 6, and g of x is 3x squared minus 10. So to find f of 6, we take the x out and we put the 6 in. So we get negative 66 plus 6, or negative 60. If we're doing g of x, we want to find g of negative 3, we take the x out and we put the negative 3 in. So we get 3 times 9 minus 10, which is equal to 27 minus 10, which is equal to 17. So evaluating means to pull the x out and plug the number in the parentheses in. Okay. Sometimes we're given f of x and we need to find x. So for example, we're told f of x is equal to 3x minus 5. We want to find x when f of x is equal to 10. In this second example, we want to find x when f of x is 2 times the absolute value of 2x plus 4 minus 6, and f of x is equal to negative 14. So in these, well, f of x will equal itself, correct? We all agree? F of x, f of x. So if I plug in the equation on the first part and the value on the second part, I have created a solvable equation. 3x minus 5 is equal to 10, and now I can solve for x. I'm going to add 5 to both sides. This will give me 3x is equal to 15. Then I will divide both sides by 3. And this will give me that x is equal to 5. So when f of x equals 10, x is 5. Using our next example, I want to find the value of x when f of x is 2 times the absolute value of 2x plus 4 minus 6, and f of x is 14. So I'll set those two things equal to each other. And now I have an equation I can solve. Now to solve an absolute value equation, I need to isolate the absolute value, so I'll add 6 to both sides first to get rid of this portion. This will give me 2 times the absolute value of 2x plus 4 is equal to 20. Now I still need to get this absolute value. So what I'll do is I'll divide both sides by 2 to cancel these 2's out. And that will give me the absolute value of 2x plus 4 is equal to 10. Now when I have absolute value, remember that the absolute value of 10 equals 10, and the absolute value of negative 10 equals 10. So to solve an absolute value equation, I have to split this into two equations. 2x plus 4 equals 10, and 2x plus 4 is equal to negative 10, to find out which values will work. So I'll solve each of these. I will subtract 4 from both sides. I'm going to go ahead and do that to both equations at the same time. I hope that's not too confusing because the step will be the same, subtract 4. In my first equation, this will give me 2x is equal to 6. In my second equation, because I subtracted 4, I'll get 2x is equal to negative 14. And then in both equations, I'm going to need to divide by 2, so I'm going to go ahead and do that to both equations at the same time. And I will get x is equal to 3 or x is equal to negative 7. So when f of x is equal to 14, I have two possible values for x that will work. We can also combine functions. If I have f of x is equal to 3x minus 2, g of x is equal to negative 6x plus 4, and h of x is equal to 1/2 times the absolute value of 2x plus 6, we can find combinations of these. For example, I can find f of 3 plus g of 2. So what I want to do is, because I've got f and g, I'm going to use both f of x and g of x. Let me just find my next example just so I don't run out of space. This is going to be tight. Okay. F of x is 3x minus 2, so f of 3 is going to be 3 times 3 minus 2. Now, I'm going to go ahead and put that here to represent that that's f of 3. And then I'm going to find g of 2. G of x is negative 6x plus 4, so g of 2 is going to be negative 6 times 2 plus 4. This will give me 9 minus 2 plus negative 12 plus 4. I'm going to go ahead and move this up here. That will give me 7 plus negative 8, which will give me negative 1. So my combination of these two functions will result in a negative 1. For h of negative 10 minus f of negative 10, h is 1/2 of the absolute value of 2x plus 6. So I'm going to write 1/2 times the absolute value of 2 times negative 10 plus 6. That's h of negative 10 minus f of negative 10, which will be 3 times negative 10 minus 2, coming from my f of x. This will give me 1/2 of the absolute value of negative 20 plus 6 minus negative 30 minus 2. And that will give me 1/2 of the absolute value of negative 14 minus negative 32, which will give me the absolute value of negative 14 is positive 14, so that's going to give me 7. Minus a negative is happy, so that's going to be plus 32, which will give me 39. And finally, for our last example, you'll see I have some extra things going on. I've got a 2 out front. That means I'm multiplying g of 3 times 2. I'm adding h of 4 to that, and then I have some plus 5 out in the end. And that's okay, we just add that at the end. So I'm going to have 2 times g of 3, so that's negative 6 times 3 plus 4, coming out of our g of x up here, plus h of 4, we use h of x, so I have 1/2 times the absolute value of 2 times 4 plus 6. And then I have a random plus 5 on the end. So that'll be 2 times negative 18 plus 4. Negative 6 times 3 is negative 18. Plus 1/2 of the absolute value of 8 plus 6. And again, I have a random plus 5 on the end. That gives me 2 times negative 18 plus 4 is negative 14. Plus 1/2 the absolute value of 8 plus 6 is 14. Plus 5. So that'll give me negative 28. The absolute value of 14 is 14. Half of 14 is 7. So plus 7 plus 5. Negative 28 plus 7 is negative 21 plus 5. Negative 21 plus 5 is negative 16. So that's how we can combine our functions. Basically, take the function that they speak of, plug in the number, and then when you get the number for each of those functions, you do the extra things that are being added to it. So multiplying that by something, adding them together, adding a random number at the end, subtracting a random number at the end.